Hi everyone, welcome to Hope's class. Today we will look at the average rate of change and the instantaneous rate of change. The average rate of change refers to the rate of change of a function over an interval. It corresponds to the slope of the secant connecting the two endpoints of the interval. To determine the slope of the secant, we could use the difference quotient, substituting the coordinates of the endpoint into the equation. Instantaneous rate of change refers to the rate of change at a specific point. It corresponds to the slope of the tangent passing through a tangent point. Okay, let's look at one example. Consider the equation y equals to x squared. So part A asks to sketch the graph over the interval from -2 to 2. So here is the graph. Part B is looking for the average rate of change of y over the interval from 0 to 2. So here is the secant over the interval 0 to 2. Recall that the slope of the secant is delta y over delta x. Using the point 0, 0 and 2, 4, solve for the average rate of change is 2. Okay, let's continue. Consider the same function. Part A is looking for the graph over -2 to 2. Well, here's the graph. So part B asks for the average rate of change of y over the interval from 0 to 1. Use 1, 1 and 0, 0. Solve for the average rate of change is 1. Well, part C is similar with part B. They're looking for the average rate of change between 1 and 2. Same method. Solve for the average rate of change is 3. Okay, same function, same part A, and the part B asks us to sketch the secant line for 0 to 1 and 1 to 2. So here's the line of the secant for the interval 0 to 1. Well, also for the interval 1 to 2. So part C wants us to estimate the instantaneous rate of change at axis 1. After sketching the tangent at axis 1, we find out that the tangent line between the two secants that are 0 to 1 and 1 to 2. A reasonable estimate for the slope of the secant is 2, or the instantaneous rate of change when axis 1 is 2. Okay, discussion. Still the same function y, it is x squared. Part A, they want us to sketch the graph for 0.5 to 1.5. So here's the graph. Part B wants us to estimate the instantaneous rate of change at axis 1. We can use the average rate of change to approach the instantaneous rate of change. Slope of the secant between 0 and 1 is 1. So same reason, the slope of the secant for the interval 0.5 to 1 is 1.5. What if we try to find the instantaneous rate of change at axis 1? We could sketch the tangent first by using the same formula that gives us 0 over 0. Wait, what? 0 over 0? That's undefined. In our next session, we will talk about the limit to explore this concept deeper. Thank you. For more information, please search the Toronto Teacher Hope in YouTube.